All right, guys, we're going to go ahead and we're going to jump into our review for your quiz. The first thing I want to say is that we need to remember that when we are taking our quiz and preparing for that, looking over our notes, that we need to understand the difference between chemical and physical properties. So let's just take a second to look at that. So first of all, we have some physical properties seen right here on this slide. And so physical properties are all going to be properties that you can easily measure or observe without a chemical change. So I can easily look at the color of something, I can measure the density, the mass, I can tell whether or not something is elastic, I can look at the volume, the luster, all of those things can be easily understood, observed, without having to actually change that substance. And I also want to remind you that when you're looking at these different properties, density is equivalent to mass divided by volume, okay? And so that stands to reason that density, mass, and volume are all going to be physical properties of matter. Today we talked about these chemical properties, right? So these are all chemical properties. Let me go ahead and switch colors for you right here. And chemical properties, in contrast to the other properties we discussed, the physical properties, chemical properties, they are going to require a chemical change. Now, a chemical change is the same exact thing as a chemical reaction. So whenever we change something chemically, we are also causing a chemical reaction to take place in order to do that. Okay? And when a chemical reaction occurs, you have some different ways to know that that has happened. The first thing you could see is that there's going to be some kind of an odor that is given off. There could also be gas, and if you notice bubbles rising from something, that is in fact a gas. You could also experience some kind of a shift in energy. And so usually these can, most of these chemical reactions are going to be exothermic, where they're basically going to get hot because what's happening is certain chemical bonds are being released, but we haven't talked about that yet. But the idea is it's going to give off energy in some way. There can also be some kind of a solid precipitate that is formed. So if you mix two containers together, like if you look at this flask right here, and I were to, pour that into something that has another chemical in it, and you notice some substance kind of collecting at the very top and kind of falling down, that's what would be called a solid formation or a solid precipitate, kind of showing up in that beaker. Going over here, toxicity is going to be one of those chemical properties. Flammability, one that we talked about in class that kind of goes along with these chemical properties, would be combustibility. And just to remind you that this is something that's a little bit different from flammability. This has a higher flash point, so you have to kind of have the substance get hot before it begin to burn. But what all of these have in common is, in order to observe them, you are going to need to have some kind of a chemical reaction. You cannot just look at something without doing something to it to know that it has these chemical properties. All right, let's go ahead and delete this. Look at the new one. All right, so here we have, and the one thing I forgot to mention there was the light given off. So these are all indicators of chemical reactions. But the one thing that's really important to remember is that when you have a chemical change, so you have a chemical change, you are always going to have a new substance. You will always have a new substance. Remember that word substance just means a type of matter. And so you can see here with this, let's just kind of look at these different pictures. I'm going to kind of, let's see, I guess yellow would be a good color to go for with this. All right, so if you take, you can do this at home too in your kitchen, but if you take a lemon and you were to drip that lemon onto some baking soda, what will happen is you're going to see like little tiny bubbles form, and those bubbles are actually going to be carbon dioxide that's given off as you have a chemical reaction. Now, here's what's going to happen. Once you have that reaction take place, if you try to do it again, it's not going to work because that is no longer baking soda. You change that into something else. So this is no longer baking soda. It's going to be something else entirely. It's not going to react anymore. You might have a little bit of juice left in lemon, but the idea is you're going to have a new substance, something entirely new. Let's look over here at the wood that's burning. So as this wood is burning and breaking down, the wood is no longer wood. The wood, and I'm going to use an arrow for this, and you'll thank me later, the wood is going to become ash, mostly carbon that's left over after that burning takes place. Going over here to the to this other illustration with the nails, again, you have iron nails, and when those iron nails rust, it's going to become what we call iron oxide. If you look at the formula, it is not the same thing. It's kind of organized differently. And we haven't done chemical formulas yet. That's a little bit high level. But the idea is every substance that exists, and you probably know this one, H2O, all right, that's the chemical formula for water. So what you can see from this is that as you are going through a chemical change, you are going from having one substance to something else that's entirely different. These are not reversible, right? So with a physical change, if I'm going to have ice melt, I can always refreeze that back into that ice later on if I wish. Over here, we can kind of see some light given off, right? So the one that, and I don't like to kind of say that these are two different ones because both are doing the same thing. Essentially, you have energy that is being released into the environment in some way. Sometimes what you can see is that things will get cold when they react. That's another kind of energy change. It's using the thermal energy around to do something. And here you can kind of see, this is not really the greatest picture, but again, a solid precipitate that is being produced. And one of my favorite reactions with that would be lead nitrate. And what you'll see in that reaction, if I can find a video of that, I'll show it to you in class. But you start out with two test tubes, and they both have a transparent liquid inside. And if you mix them together, what's going to happen is you are going to get a substance that is going to be clear at the top, but you'll see this like yellow powder begin to collect and just kind of like fall down and kind of collect at the bottom. And that's what we call it a precipitate, because it collects it just like rain is precipitation. So you have the solid is formed at the very top and begins to rain down within that liquid. It looks really cool, but it's not safe for our classroom, so we're definitely not going to be doing that one. But just understand that all of these things are signs that a chemical reaction has taken place. And I want to reiterate this and kind of make sure that I've explained this very thoroughly, but a chemical reaction is always a chemical change. Chemical change is any change that is going to cause a new substance to form, something new, something different, and that is always going to require a chemical reaction. So if we look at things that are just physical changes, well, these are very different, right? So it might appear different in some way, but it is still the same substance. It is still the same substance. It is still the same thing. If I break this glass, it is still glass. It's just broken shards of it. If I melt this ice, and let's stop calling this water, let's start calling it H2O. You'll thank me later. So H2O, if I melt the ice, it is still H2O. I just went from, all I did was I changed from being a solid to a liquid. That is just a state change. One point that I want to make clear to you guys, because this might come up tomorrow, on Friday, is that all state changes are physical changes. Anytime you have a change in state, that is a physical change. It is not a chemical change. Now, there are some reactions that you can have, some chemical reactions that will also cause a state change. So you can always have a physical change with a chemical change, but you need to understand that physical changes are not the same as chemical changes. If you chop wood, it is still wood. And you guys are getting the point here. If you break an egg, that is still just a physical change, but if you were to actually cook it, then it would be a chemical change. Let's take that example I was just talking about, and let's just kind of like go with something like, let's say if you were to have a candle burning, right? So let's say you have a candle burning. Now, a candle burning is going to be a chemical change because anytime you have something burn, it is always going to be a chemical change. So chemical changes, anytime you burn or cook something, those are always chemical changes because it produces something new. However, you might remember that if you burn a candle, it's going to melt. So that's a great example where you have a chemical change because the wick is burning. So you have a chemical plus a physical change happening at the same time. All right. So just so you know, there's two of those changes that are occurring, but you really want to describe those two things differently. Okay. Folding paper, again, still paper. Make sure that you are able to kind of understand that if we have a state change, because this is going to be big, we're going to have that on the test. You are also going to be having it as just a physical change, but there's sometimes can be times when we have the two that kind of come together and they're working side by side, occurring simultaneously. Now, this is something I want to show you guys. This is like kind of a little bit high level for you guys. But what we have here, this is a simple reaction that takes place in your body, right? So right here, this stuff right here is called carbonate, all right? Carbonate. And then this is, you might recognize that's just hydrogen, right? And so what we can see here is that if the carbonate, we say plus, combines with the hydrogen, what that's going to give off, and you probably recognize these two chemicals, it's going to release water and carbon dioxide. Now, a question for you. This is what's happening behind the scenes when we talk about chemical changes. This is what's always occurring. So what do you think happens to the chemical formulas of things when they go through a chemical reaction? And that answer is they rearrange. So the chemicals rearrange themselves. You don't have to right now, you don't have to know what this is called, what that's called, or what these two are called. But the idea is that behind the scenes, when all these reactions are taking place, what is happening is these formulas are changing, and those formulas change whenever there's a chemical change. Whenever there's rust, whenever we burn something, whenever you cook something, all the time behind the scenes, what is occurring is we are rearranging these chemical formulas into new chemical formulas because you form a new substance. Okay, so we don't, you're not going to have to really touch these right now. These are not that important for this point in time. But the idea is that as it goes through this change, this alteration, it is forming that new substance that is completely different from what it was. Here are some great chemical change examples. Now, the question down here is, What always results from a chemical change? And I know that you probably have gotten kind of tired of this, and you're starting to kind of lose patience here. But here's the idea: whenever you have a chemical change, you always have a new substance. And these are great examples of those chemical changes. Again, burning wood, rotting fruit, rusting metal. Whenever you use a battery, the battery has chemicals in it. They go through a reaction and they produce electricity. Again, they're having an energy. They're releasing energy. That's an indicator of that, okay? Over time, that battery is going to lose the ability to have those reactions because the chemicals have already reacted and formed something new. And that new substance is no longer reactive. Fireworks, souring milk. Souring milk is kind of like just rotting food. Okay, it's another way that it's kind of breaking down. Photosynthesis is probably my favorite chemical reaction because without it, we wouldn't be alive. So let's go ahead and let's look at that. So if we can kind of like just fast forward here and kind of move this down to this, you can see that this is a great example of a chemical change. This chemical change, everyone depends on. So again, we have a chemical change. And again, another way to say that would just be a chemical reaction. So in this reaction, we have, just ignore these numbers for right now, but we have carbon dioxide, and we have water, and we have energy from the sun that's combining with that. And when it goes through its process, it is forming glucose, which is a type of sugar, and oxygen. Okay, we have glucose and I'll just say sugar and oxygen. So these things over here that I'm circling in red, they are not the same as the things I'm circling in blue. It's a new substance. Again, we're forming something new substance. Now, going back to the properties, right? So one of the properties of carbon dioxide and water is that it can react with sunlight to form these new products, right? If I want to describe the water and say the water is clear, the water has 40 milliliters of volume and so forth, all of those things are physical descriptions. I don't have to be observing them through the course of a reaction to know that they have those physical properties. Let's kind of go back to, to finish up, I want to go back to that beginning, okay? So again, sometimes we just have physical properties of matter where we just examine the matter, we observe it, we want to see what's happening with it, what it's made from, and so forth. Those things are all going to be just base level observations that we're making of that matter. Chemical properties are things that we don't quite see unless we have a chemical reaction. We don't know if something's going to burn. We don't know if something's going to react. We don't know if something is going to be corrosive. We don't know if something's poisonous. We have to test all those things through a reaction to see that they have those properties. Okay, now if we go down here to these chemical reactions, these are the times when we can actually observe those chemical properties. But, and this is kind of like the negative here, you can only observe chemical properties during reactions, but after that reaction has taken place, you no longer have what you started with. Like, once you go through this reaction with the lemon and baking soda, you can't go back to having that baking soda be perfect anymore. It's already reacted. It forms a little, I don't want to get too far into this, but it forms a type of salt. So what you're looking at right here with a baking soda, again, once you react and you say, oh, well, baking soda is reacted with lemon, this is no longer baking soda anymore. It's something else. It changes. So that is the base of what we're talking about here. And one thing I want to encourage all of you guys to do is to take some time today and look over your notes. Your notes are great resources for preparing for that quiz. If you have questions,